So page 5 is the derivative of an inverse function. Um, so we're given the function f, we're told h is the inverse of f. We don't know what h is, and it'd be relatively complicated to actually figure out what the h function is. And we want to find what the derivative of h at the value x equals negative 14. And we're given this piece of information, f of 2 equals negative 14. I think we can probably use that. Remember, there are two critical characteristics of inverse functions. If f and g are inverses, if f and g, in this case, f and h, if f and h are inverses, f of h equals x. Okay. Remember, we saw this like with x squared and square root of x. You know, you take the square root of x and square it, you get x. You take x squared and take the square root, you get x. So if you take the function of its inverse, you always get x. So f of h is going to equal x. Make that a little bit neater. Okay. So that's the first key thing to notice. Okay. F of h would be x. The other thing is, if you've got an ordered pair for f that's like a comma b, h is going to have the ordered pair b comma a. They have ordered pairs that are inverses of each other. And again, if you go back to x squared's got an inverse. 2 comma 4 is an ordered pair for x squared. And square root of x has got the ordered pair 4 comma 2. Square root of 4 is 2. So you can use those two characteristics of inverse functions to relatively quickly solve these complex problems. So let's go ahead and clean this up a little bit here. So I'm going to start out with a basic, the more important of the two, I think, is that f of h of x equals x. Okay, f of h of x equals x. I'm going to take that simple equation and take the derivative of both sides. So the derivative of the first side, left side, is a chain rule. Derivative of f of h of x is f prime h of x times h prime of x. And the derivative of x is simply 1. Okay. So I'm looking for h prime, and I've got h prime right here. So I know that h prime of x equals 1 over f prime of h of x. Okay. Okay. I think I'm making progress. Well, what am I looking for? I'm looking for h prime of 14. So I'm going to write that down. H prime of then 14, or negative 14. H prime of negative 14 equals 1 over f prime of h of negative 14. Okay. All right. Well, do I know what h of negative 14 is? Well, let's go back here. So in other words, I have an ordered pair someplace for h that's got negative 14, right? And it equals something. I don't know what that is. But I have an ordered pair for f, which is 2 comma negative 14. Because they tell me that f of 2 equals 14. So that gives me an ordered pair 2 comma 14. Well, that means that for h, I have the ordered pair negative 14 comma 2. Didn't make it just a little bit neater. Right, I've got the ordered pair negative 14 comma 2, which means that h of negative 14 equals 2. Okay, so now this thing down here, this equals 1 over, this expression is 1 over f prime. Well, h of negative 14 is 2. This equals f prime of 2. Okay, so again, how do we get to this so quickly? I use the basic concept that the function of its inverse equals x. I write that expression, I take the derivative of both sides, f prime of h times h prime of x equals 1. Derivative of x is 1. I solve for h prime. I get h prime, a function I don't even know what it is, but I do know the derivative is 1 over the derivative of f at h of x. Okay, how do I find h of x? Well, in this case, it's h of negative 14. Well, I'm trying to look for the ordered pair negative 14. What's its value in h? Well, I know f has got the ordered pair 2 comma 14 because f of 2 is negative 14. If f has the ordered pair 2 comma negative 14, h has the inverse pair, which is negative 14 comma 2. Well, if negative 14 comma 2 is an ordered pair for h of negative 14 is 2. Okay. H of negative 14 is 2. So now this is 1 over f prime of 2. So what's f prime of 2? Well, okay. Oh, now I've got to take a derivative. So let's do that. I know that f of x equals 1/2 x cubed plus 3x minus 4. So what's f prime of x? Well, f prime of x is going to be equal to 1/2 times 3 times x squared plus 3. So what's f prime of 2? Well, it's going to be 3/2 times 2 squared is 4, okay, plus 3, okay. So 3/2 of 4. So that'd be basically 3 times 4 is 12 over 2. That's 6 plus 3 equals 9. So f prime of 2 equals 9. So this is 1 over f prime of 2. This is 1 over 9. This is my answer. Okay. And again, I start out with a basic relationship that the function of its inverse equals x. Take the derivative of both sides using the chain rule derivative. I get h prime of x then equals f prime of 1 over f prime of h of x. I've got to figure out what h prime of 14 is. I used my knowledge about the inverse ordered pairs, and I'm all set. There are a lot of steps in these derivatives of inverse functions. Students get confused, and I challenge you. Are you really confused, or are you just not paying attention because there's a lot of steps to pay attention to? I think it's the latter. You're not really paying attention all the way through. And again, you've got the whole inverse ordered pair, an easy concept to remember. I guess when you go back to, the whole concept of, x squared and square root of x. Obviously, take the square root of x and square it, you get back to x. So that's easy to understand. And the ordered pair for x squared is, 2 comma 4. If you square 2, you get 4. The ordered pair for x, square root of x is 4 comma 2. It's relatively easy to understand and hold these basic principles about inverse functions, okay, using this example. And then go ahead and apply it. Think it through, do this a couple times. This is not that bad, although there are a lot of steps.